guys, this is Amit from Networkers Home Technical Team, and today's topic is data flow. Data flow through the OSI model here. So, and we are going to be discussing about encapsulation and encapsulation in depth today. So in the previous section, we have already discussed about encapsulation and then de-encapsulation, but that was the brief idea. So today we are going to be discussing the depth here, details. So let's start. So this is encapsulation, as you know. So what is the encapsulation process when you sender side? So it's always happen on the sender side. So this is about application. So when your data comes from L7 to L6, then L6 to L5, then 4, then 3, then 2, and then 1 layer. So that is processes. And on each and every layer, then they will add its header here. So that process is about encapsulation. For example, this is a one user wanna send an email. So this guy, first of all, write an its email, whatever is the data into that. So let's consider this as some data of the email. So this is about data. So this is about application layer. About this is now directly we are on the transport layer. So on the transport layer, the data will be converted into segment. So this is segment 1. This is about segment 1. This is not a segment here. So this is about data, again, same data, but that is not a segment. Then on L3 layer, we'll add network header, and L2 layer will add will add frame header and the frame tailor to, and then it will convert into form of bits, and then we'll forward to the destination side here. So how we will okay. So this is all about kind of encapsulation. So let's start. So now let's consider these are the two devices. This is PC1 and this is about server. And on the server, we have enabled HTTPS service at port number 443. So what we have to do, we have to go to the browser of this PC. This is considered the browser of this PC. And then we have to browse like this way, HTTPS. And then we have to browse the destination server. So we can use here 10.1.1.1.2, or you can use its domain name as well. That is HTTPS and about server1.com over here. So I'm not going to be add here any DNS concept. So directly I'm using here 10.1.1.2, but you can use this concept as well here. It's up to you here. So let's consider when you will use here HTTPS and you want to access this server. So this is some of your data. Let's consider this is some data here. You want to transfer to the server, or maybe you want to access this server from here. So how it's going to be possible? So first of all, this is data. This is your actual data. So this data will be where it will comes to your application layer. On application layer, now we are going to be select here the protocols. We have options HTTP, or we have option here HTTPS also. As you know, HTTPS is all about not secure, but HTTPS is all about secure, all because of SSL. Okay, so this is here kind of what we are using, one of the remote VPN that is known as clientless VPN we are using. And about the VPN, so you will get to learn and the security section here. So this is what HTTPS secure. This is all about all because of SSL, and SSL is all about the remote VPN, and that is also known as about your clientless VPN here. Okay, that's the data. And now let's consider we have decided which protocol we are going to be used. We are going to be use HTTPS over here. So first of all, data will come from where to where? It's from application. Then on application, we are going to be use here what? We are going to be use HTTPS protocol. We are going to be use which protocol? It's going to be use HTTPS. It's about in front of that, it's all about HTTPS header will be here. It's all about HTTPS header. It's about HTTPS header. After that, it will comes to your now, and this is also known as here data. This is what are the PDUs we are going to be used. If I'm talking about the PDUs here, protocol data unit. So what are the PDUs over here? So that PDUs are on application layer. That PDU we are going to be use data. Presentation layer again, all about data, and session is also data here. So these are the PDUs which we use on these layers. So these are the PDUs. So the thing is, first of all, it's data, and data we will add HTTPS header. Then it will come to your presentation layer if you are using any kind of encryption. So let's consider you are using any kind of encryption. So at this layer, then what will happen for the data? Then it will decrypt your data here. If any kind of encryption you are using over there, so then it will perform kind of encryption here. It will perform what kind of encryption? Now, so this data will be into the encrypted format. After that, we'll forward the now presentation will forward the data to the session layer. That what the session layer will do, if you're using HTTPS and all, so then it will create the sessions for that. It will create the session for this data here, and after that it will forward the packet to the transport layer. So now the transport layer will create one segment here. It will create one segment. So let's consider if we are using HTTP protocol. So how the data will be looks like. So let's consider this is data which we are sending from client to server. So this is kind of source IP. We'll add destination IP into that. Okay, source MAC and destination MAC. Source MAC, destination MAC, source port, protocol, destination port, and all. So it will add so many parameters. So this is all about the data. The data is what? That is in the encrypted format here. So this is all about data, and this is also known as payload here. And as okay, so we're going to use here source IP. We're going to use here destination IP. Then it's all about source MAC, then about DMAC, then about protocol, then about source port, and then about destination port. So now, so transport layer means which protocol we are going to be used here. So we have option for TCP, and then we have option for the UDP. So if we are talking about HTTPS, if you're talking about HTTPS, so it use which transport protocol? It's use always your TCP, and its port number is 6 here. And what's the port number? What this port number here? Port number is all about 443. Which protocol does it use for the security? It's about SSL here. So this is to secure. So now at transport layer, first of all, they will decide it because there is an option for TCP and UDP. So it's all about HTTPS. So now transport layer will decide it. TCP is all about, so HTTPS is all about TCP. So let me add its protocol number here. What is the protocol? 6 here. Then it's all about source port. So now it will decide its source port. So if we are talking about port assignments, port numbers. So there's a different port numbers. It's start from 0 and it's end up 65,535 over here. So there are some non-port number, or you can say these are the reserved port numbers here. So they're known as reserved port numbers. Its range is 0 to 1023, and then random port number here. And about random port number. So what are the random port number range? 1024 to 65535. So these are the well-known port number like Telnet 23, right? Then about SSH about 22. Then about FTP, file transfer protocol. It's all about 20 and 21. Then about HTTP, all about port number 80. So like this way. So these are the what? These are the non-port numbers, or you can say these are the reserved port numbers. But the random port number we always use for the source port concept. Mostly we use for the source port. Now, what is the destination port? Because this is about transport layer. What is the destination port number? So we are using which protocol? We are using here HTTPS protocol. So what is the HTTPS protocol number here? Here, which service we have enabled? HTTPS and port number 443. So by default, what is the destination port? Destination port is about 443 here. Even we can customize the port numbers, but we are not customizing. We are using default port numbers. After that, it will mention the source port. What is the source port number? That is all about the random. And what is the range for the random port number? This one. So let's consider the random port number is going to be used now. For example, 2050 here. Okay, it's from the which series? From the this series, but not 242.655.35. Should be between this series. After that, it's in a segment. Now it will add TCP header on top of that, in the front of that. So let's consider this is a data presentation layer and all. So this is session layer, and now this is data here. This is data, and this is the data here, and the data is in the encrypted format. And now this is the data, and in front of that, then it will add. So this is HTTP header first. It's all about HTTP header. Then we'll add TCP header. So this is all about HTTPS header, and this is all about TCP header. TCP header. Its size is 20 bytes. That is 20 bytes. So now this is fine. After that, it will forward the packet to the network layer. On the network layer now, which routed protocol are you going to be using? Are you going to be using IPv4 or IPv6 here? So as we know, we are using IP address 10.1 and 10.2. It's all about IPv4. So we are going to be using here IPv4 here. So in the IPv4 now, what is the source IP? Source IP is 10.1 and destination is, you have mentioned, itself 10.2 here. So then in source IP will mention 10.1.1.1 IP, and then and the destination will mention 10.1.1.2 IP. This is fine. So it means what it will do again, this is network layer now. Now, what it will do, this is then same data, then HTTP header, then TCP header. Okay, and after that, your HTTP IPv4 header. Like this way. Okay, so this is again what? This is all about data here. About data. It's all about HTTPS header, then all about TCP header. And now this is all about your IP header now. And its size is again all about 20 bytes. 20 bytes. This is all about header. Further now, it will be forward to the data link layer. Now again, data link layer will add what? It will add its own header in front of that. It will add its frame header, its header, and then it will add one trailer as well, FCS trailer. So this is header, and this is trailer. Further, it will be moved to the physical layer, and that it will convert in the form of binary here. Whole data. What this will do, this is the data here, and this data will be converted into the binary formats. So that is 0101. This is all about bits. That's it. Okay, and finally, this data then will be sent on the wire. So this is on the wire here. So now this data will be travel over the wire like this way. Finally, data will reach to its destination. Then first of all, it will reach to the physical layer. Then physical layer will again convert into the what? Into the form of data here. So again, it will convert what? This process when it's all this process is what? This process is known as encapsulation. This process is known as encapsulation. This process is encapsulation. And then here, everything will happen in the reverse direction. So first of all, physical to this layer here, okay? Then this layer to the just about physical layer, then it will reach to the data link layer here. Data link layer will check its. Now, see, before last time, the source MAC was AA and destination MAC was BP. Okay, so this is the what's the source MAC? Source MAC is about AA here and destination MAC B here. So my okay. So now finally de-encapsulation will happen. This data, these bits, the data in the form of bits will reach to the server side, and then server will again convert into the bits to the now data will to the data link layer. So this process in the reverse direction is known as de-encapsulation. So it will check the data here. Okay, and here actually, guys, all the same headers will be there. These are all the headers. This IP header, then TCP header, the CTP, and then about data here. Okay, then it will check its source MAC and destination MAC, exactly what is the source MAC from where the data is coming. So first of all, it will check what the destination MAC, it's BB. What's my MAC address? My MAC address is B itself. It's coming from where? A only. So, okay, that's fine. So it BB is my MAC address. So it means this data is for me only. After that, it will move to the next. There's the next layer. So now, so this is what? This is de-encoded. It's they decoded this first layer. This is about this layer here. So now it will remove this header from the packet here. This header and this is about trailer. Not required. After that, we'll reach where? We'll reach to the next layer. That is about L3 layer here. So on L3 layer, then it will check it. What's the destination IP? So first of all, destination IP is 10.1.1.2 and it's 10.1.1.1.2 here. And what is my IP? My IP itself is 10.2 here. So it means this packet is for me. Then it will check its source IP from where is it coming? 10.1 here. That's fine. 10.1 is also fine. Then it will check it. What is the protocol number here? Then because it will be added into your IP header itself. Then it will check it. What the protocol number? It's about 6. So now on layer 3 itself, guys, you will get to know at layer 3 itself, you will get to know means at layer 4, which protocol is it? Is this data is using which protocol? So it's mentioned here 6. So now the data will get to know, will get in a basic idea means in the upcoming layer, which header will be there? Definitely TCP header. So then further data will be moved to the next site. So now this time it will remove which header? Will remove TCP header. Then finally, this is what? It's about a TCP header. In the TCP header, what will be mentioned then? Then it will move this one over here, guys. Further, we'll move to the next one. So this is all about what? TCP header. So in the TCP header, what is the destination port? Then it will check destination port is what? 443. So what is my port number? My port number is again same. 443 is already enabled here. Then means this is for me itself here. What's the source port number? Then it will mention, it will take care about the source port as well. It's about 2050. So then it will remove the TCP header as well from here. So further, it will then goes to session layer. So then it will use, then session layer will help us to keep the session separate over here behalf of its source port. Then it will goes to the presentation layer. As per the presentation layer, as per the supported features, now the data will be present to the server. And then finally, it goes to the application layer. And which protocol we are using? We are using HTTPS over here. And finally, data will be data to the destination. So this is about what? This is all about your de-encapsulation. So this process, the reverse one, this is known as de-encapsulation. So this is all about what? This is all about client to server. Now it's time to send reply back. Finally, it will open the packet, open the data, and then now it's time to send the reply back. So as for the reply, it's now server to client. In server to client, then same. This is here. And then finally, this is about data here. This is the kind of reply of the same data. And okay, and this is again data from this one. Server to client, source IP, destination IP, source port, destination port. Now, so from the another side, from server, what the server will do? Server will again will generate. Now it's time for reply. So again, what? This is kind of what now? This is kind case. This is data, and this is reply actually. This is again what? This is all about data, but this is all about reply data. Reply. So again, it will encapsulate it. Okay. Again, it will add what? First of all, it will add your HTTP header, HTTPS header over there. So first of all, we'll add HTTPS header. Then it will come back to presentation layer. Now it's further will to the presentation layer, then about session layer over there. After that, it will come to the session layer, and then finally to the transport layer. So after that, on the transport layer, this is the data. This is HTTPS header, and then further we'll add what? TCP header over here. So this is data here. This is about HTTPS header, and now which header? TCP header. So as per TCP header, so it will add all the details. It will add which protocol number, protocol number is 6. What is the source port? Now during the reply, the source port is 443, and what will be the destination? 2050. So means this is about this one. So this source port is about here, and this is all about here now. Okay. After that, it will be come on the next layer, that is about network layer here, and then further it will add here one more header. So this is all about IP header. So this is about IP header. In IP header, it will mention source IP and destination IP. What the source IP now? Source IP is 10.1.1.1.2 and destination is 10.1.1.1. Okay, so again it will reverse on that because now time to sense reply back over. It's all about reply. Source IP and then about destination IP. This one. Finally, after that, it will be now to the next layer. So here we'll add frame over here and then frame header and then trailer. And this is about frame header here. Frame is all about header and this is about trailer. Then it will add source MAC is now PB and destination MAC is about AE over here. Okay, so this is source and this is destination. Will exchange, but the protocol between them will remain same. It will remain same over here. That's it. So finally, again, this packet will be converted into the form of bits here again. Finally, the data will be converted into the form of bits. Same. This is all about reply. Reply over here. Finally, this is here now. Again, this reply will be now forward to the this one over here. Headers. So this was what? The blue color, this was all about kind of request, or you can say PC to this one here. It was like this way. And now this is all about reply over this direction. Okay. So this is here finally encapsulation. So again, what is happening here? So this is again what? Kind of further it's coming back over there now, like this way it's coming. So this is about what? Kind of encapsulation. So further once it will reach to the destination, what will be there? again your de-encapsulation will happen. So then finally it will reach to the like this. So again it will check it on the destination side. First of all, it will reach to the physical layer, then it will forward to the data link. Data link will check it versus destination MAC. It's about A, my address is already A for me. Then network layer will check it what the destination IP 10.1, 10.1 means it's for me only. Then it will go to session layer will check it which protocol, 6 itself, what's the destination port, 2050 and 443. So then transport layer will get to know, okay, on the transport layer, then it will get to know, okay, yeah, previously I have sent one request for this source port and with this destination port, and now I'm getting the reply for that. And finally, it will de-encapsulate your data, and finally, we will receive the reply where we will receive the reply over here. So this is, guys, data flow from first of all, client to PC, so client to server, and then about server to client here. After that, server to client here. So first of all, it's now what encapsulation will happen, and then on the another side, and so this is about de-encapsulation. So this is about de-encapsulation. So in the encapsulation at L4 layer, at layer 4, we'll add, first of all, layer 7 will add HTTPS header. Then layer 4 will add TCP header. Layer 3 will add IP header. Layer 3 IP header. Then layer 2 will add here frame header and trailer. Tailor, actually, it's there tailored here. And then L1 will convert into binary. Okay, binary numbers, or you can say into bits. Okay, so this is about 7. This is all about step 1. Step 1 here, client to server. So then on the another side, what happened? So first of all, at L1 layer itself, now convert bits. What it will do, it will now convert bits into data. Then L2 layer will check destination MAC, will check here, source MAC will check destination MAC. Then L3 layer will check, at L3 layer will check its source IP and destination IP. And after that, here it will remove frame header. Okay, it will remove what? Will remove frame header from there. Then here it will remove IP header. Then L2 layer. So it's all about, so this is about L4 then. At L4, then we'll check destination port and source port. And after that, we'll remove TCP header. It will remove which header? TCP header again. Then it will go to L5, then about L6, okay, and then about L7, and finally remove HTTPS header over. Okay, so this is step 1, and now step 2 is again same. In the step 2, this is server to client, and this is client to server, and this is your client side here. This is server side, and that is client side. So this is about client here, all about client, and this is all about server end. So now here again, server. So first of all, what happened now? Again here, what happened? Again here, encapsulation will happen. Now again, encapsulation, and then on another end over here, step 2. So this is de-encapsulation. Encapsulation. So this is about client to server, and then it's about server to client over here. This one. Okay, so this is, so first here, step 1, step 2, then here step 3, and then step 4 over here. Okay, so this is over here. Okay, encapsulation on client side, or you can say client, or you can say sender. I can use a sender side, then the encapsulation on receiver side, or you can say server side. Okay, so this is kind of like, then again encapsulation on the server side. Now again encapsulation on server side, and then again the encapsulation on client side. So these are the steps, about 1, 2, 3, and 4. Okay, so this is all about your data flow from application to physical, and then physical to application, about encapsulation and de-encapsulation over here. So encapsulation, then de-encapsulation, it's in the reverse direction. We are just done with that. So we are done with the encapsulation and de-encapsulation, or you can say data flow through the OSI model. So thank you for watching the videos, guys. See you in the next video.